Good morning, everybody. Lovely to be in Florida now. Actually, I'm from north of Toronto, so it's lovely to be anywhere. Lots of snow on the ground at home, and of course, cold temperatures. So it's nice to be down here where you can actually work up a sweat without doing anything. It's very nice to see some old friends in the group, and very nice to see all of you. But certainly under these circumstances, this is something that has been of great interest to me for some time, and I would say that it has been sort of lingering in an almost subliminal way just beyond my ability to draw in and organize properly. But the more I thought about this, the more I thought how critical it is to address this particular part of our business, because with all due respect and great affection for all my colleagues, I don't think it gets the attention maybe it deserves. First and foremost, people like us love the sexy stuff. We love the chemistry and the lights and the visual and the now moment of finding something important in a big case. And that's great. But I think every once in a while we have to draw back for a broader look at the whole picture to see that the direction we're moving in is the correct direction, and that we are using the funds allocated to us in the way that they are best devoted. So certainly we have a sense of our mandate, and I think sometimes, I know in my career I got kind of removed from that mandate, but it's important to draw back and look at your roots every once in a while. You know, the old existential business of why are we here. And it's good to remember that we are not dollar driven. Our business should be entirely event driven. That doesn't mean we're not dollar dependent, because we are. We are living in a world of diminishing resources and increasing demands for service. But we have to keep reminding ourselves that it was never our mandate to either generate revenue for our department or save our department money. It's good if we can do that in a responsible way and still maintain our primary mandate, which is to find physical evidence to the best of our ability, and then take that through the court system to basically solve crimes and make the streets safer. So I don't want to get too preachy on you here, but as I say, we have this tendency in our business to get to the fun stuff, and every once in a while it's good to draw back and look at the overall picture. So I'm going to talk a little bit, this is a little bit misleading here, it says the history and evolution of Indanedione, but the title of the workshop and all is Getting All of What's There. And we're addressing the issue of sequential processing on documents. So I'm going to take you on a little bit of a history trip, first of all, which kind of builds and leads toward the ultimate statement or position that Alexandra and I are wanting to leave you with. And that is the essential nature of sequential processing on paper exhibits. Something that has been within our grasp for a long time and for a lot of reasons has not been exploited to the maximum. So some things to think about. And along that road, I doubt that there's anything that is more complex, more fraught with frustration than the processing of documents for fingerprints. We have contamination issues there that seem to be more telling, more ultimately impacting on our final results than almost any other aspect of our processing program. And with apologies to those of you who have attended my workshops and have heard this before, it's one of my favorite little stories, and it illustrates actually what we go through. There was the famous researcher who was doing a series of controlled experiments with fleas, and he had a flea on his lab table, and he ordered the flea to jump, and the flea jumped. And then he removed one of the flea's legs, and he said, "Jump," and the flea again jumped, and he wrote this in his log. When one of its legs was removed, the flea continued to jump on command. So he would systematically remove one of the legs each time, and each time when he ordered the flea to jump, it jumped. Finally, the flea has one leg left, and he said, "Jump," and the flea flexed its leg in an attempt to jump, and he wrote that in his log. And then he took the final leg off, and he said, "Jump," and of course the flea just lay there, and he wrote in his log, "Important scientific breakthrough: when you remove all of a flea's legs, he becomes deaf." And folks, we do this all the time in our business. There are so many factors involved, and there are so many frustrations because we can often be barking up the wrong tree because we haven't considered them. And it has impacted and attenuated some of our research because we were not. I've seen very respected groups of researchers from different parts of the world researching exactly the same chemistry, but coming up with radically different results. And both of them worthy, but because one or more factors was not considered, conclusions were drawn that that was better than or not as good as another reagent. So now we're just going to go into the history a little bit of fingerprint development to show you how these things have impacted over the years. So our techniques have always been and continue to be dependent on the surface. So the first breakdown in surface in exhibit triage has been porous and non-porous. And some of those, even within those, have very specific properties that we many times have not been completely aware of. And I think it's safe to say, without having lived back then, although sometimes it feels like it, powder was the first organized detection technique for latent fingerprints. And it was probably just an example of serendipity, as I call it, just a very happy accident where some type of powder, one can imagine soot or charcoal or even something edible, was spilled onto a surface that had latent prints deposited on it, and then the powder clung preferentially to that sticky part of the surface. So we can see how that would happen, and then somebody went, "Wow, this is cool," although they probably didn't say cool in the 1800s. And then they would proceed to develop that and improve it and refine it to the point where we now have very sophisticated fingerprint powders. So they haven't changed, essentially, in what they do. They have improved the performance of them, but the concept of fingerprint powder hasn't changed since the late 1800s. And it's important for us to recognize, certainly in the sense and direction of this workshop, that there are very, very specific fingerprint ingredients that we view as targets for our techniques. And the ones I'm going to mention are just a few of the highlights, when in fact there are literally hundreds of possible target or component ingredients in an absolutely limitless range of combinations and percentages. It's an intensely complex picture, and it does explain, at least to me, why on occasion stuff happens that I can't explain, why we get a particular result when we were expecting something else. And certainly I've found in this business, as I've stated on the stand before, that I don't have any particular expectations when I approach a job because it's a lot less painful. And I'm wondering if anybody could nod their head who've had that kind of expectation and had it disappointed. If you've been in the business for a little while, chances are you've had that happen. And if you haven't, you're doing great. Whatever you're doing is working. So as I mentioned before, it is a very complex business. So we have, first and foremost, we have the sebaceous oil, which is something that we secrete on all parts of our body except for the soles of our feet and the palms of our hands. But we do get a transfer by touching our faces and our heads on a regular basis. So there's usually some sebaceous oil there ready for deposit when we touch other things. We have sodium chloride, common salt, and a lot of other inorganic salts as well. We have lipids, and we have amino acids. And there are other things like uric acid, urea, and so on, but these are kind of the main group. And did some research on this and found out that there was a gentleman named, I'm going to ask my colleague here to give me a pronunciation on that. Forgeot? Close enough for government work. That's what I'm going to go with. Forgeot in 1892 was a colleague of Bertillon, which should be, I guess, Bertillon. And he explored silver nitrate for the first time. So silver nitrate's actually been around for a very long time. And in 1932, Dr. Hudson used silver nitrate in the Lindbergh baby kidnapping. And he used it in a kind of a new and atypical way. He used it on the ladder that was used in the part of that whole scene. And it's kind of surprising because that is another famous case that was really messed up right from the get-go. And it seems that in our business we reserve our worst work for the biggest cases. And I guess the good news out of that is we often get very good developments out of it, very good knowledge. Sometimes the best knowledge is don't ever do that again. But in this particular case, I was surprised to find that the references to the use of silver nitrate in this case are very obscure. And I've been able to find this only in one book, and no other examples, no papers written on it that I could see. So people in our business were not yet at the stage in 1932 where we had a vehicle or the inclination to publicize our findings, to bring them to the attention of colleagues so that they too would be able to exploit these properties. So no papers written that I could find. And in the 1940s, ninhydrin came along, and ninhydrin was a presumptive test for a protein, and they were using it to see amino acids on chromatograms. And in 1955, a patent was granted to Odin and von Hofsten for the usage of ninhydrin to develop fingerprints. So it had been around for a long time, but this was the first time someone had actually taken it in a different direction, a new application for it. And I come back to silver nitrate, and it was the first technique for porous surfaces, for papers and cardboards and wood and anything of that kind of surface. Anything that would not typically respond well to powder. And I have seen some incredible sights in my career. I've seen, on rare occasions, fortunately, but I have seen people using powder in relatively recent years on paper exhibits that weren't handled. I see a few heads nodding. Not your best shot, and I think we know that pretty much as a group. But, and again, that we come back to why we're all here. It's to sort of make sure we don't lose $10 on the race and 10 on the replay. To make sure that if we have made a mistake or done something that would have been done better, that by saying, you know, mea culpa, somebody else down the road can avoid making that same mistake. But anyway, silver nitrate was the first technique for porous surfaces. And paper, cardboard, wood, and the detection target was sodium chloride, just common salt. So what would happen is that the silver chloride that was formed, the silver nitrate would react with the sodium chloride to form silver chloride on the surface of the paper or the cardboard or whatever, and then it would become light sensitive. In a sense, it was almost like creating a photographic emulsion on the surface, because all of these salts from that chemical group, the salts of iodine, bromine, and chlorine, were all light sensitive and were used in the production of film. So this would darken on exposure to light, and you would get, in many cases, very good fingerprints. Problem was, the big Achilles heel here is that it's easily affected by humidity. We all know how soluble in water common salt is. So if you have conditions, ambient conditions that are very high in humidity, and no one who lives in Florida is a stranger to that condition, you can have some problems with this technique. And it also explains why this was not a great or well-accepted technique in certain parts of the world or this country. So the salt would migrate from the ridge sites, that is, on exposure to that inordinate percentage of humidity, it would start to bleed out into the paper, and when you process with silver nitrate, you end up with nice, soft blobs without ridge detail. Just out of curiosity, has anyone in the class ever had that experience, or has anyone here used silver nitrate for paper? That reassures me, because I thought I was part of a generation that included the hoop skirt and ice boxes. So the ridge detail would quickly degrade in this kind of humid environment. And then in the range, I'm going to say 1950 to 1970 roughly, there was a slow emergence of ninhydrin as the reagent of choice for porous exhibits. And in my case, it was extreme. It was almost overnight. The ninhydrin targets amino acids which are not affected by extremes of humidity. And as we all know, they are affected by out-and-out immersion in water, but because they are soluble in water. But in terms of humidity extremes, they appear to be pretty much impervious, far, far beyond at least what the sodium chloride was. And ninhydrin proved itself to be effective on a wide range of paper and other non-porous surfaces. I've had some just absolutely wonderful stories submitted to me about success on things like not only papers of all kinds, but hockey sticks, drywall, painted drywall, and in one case on a pillowcase. And that one really amazed me. Not so much that it worked, but that the person had the thought to try it. Like I never would have thought, I'll be honest, I never would have thought of using ninhydrin on a pillowcase. But that was the only exhibit they had in that particular case. And in the write-up, that individual actually included the thread count on the pillowcase. And it had to be a very fine thread count to give you the continuity of detail, but it ultimately was pivotal evidence in a homicide investigation. So it's been effective on a wide range of paper and other non-porous surfaces, and is in mainstream use in the present day. And I have to tell you too, lest it be thought that I am denigrating or diminishing ninhydrin in any way, I had wonderful success with ninhydrin through the great bulk of my career. It was our bread and butter first line reagent for paper, for anything porous, and I just love the stuff. But so I wanted to make that quite clear up front. And I've been around, I consider to be in one of the most exciting periods one could actually be alive and be employed in this business, because in the last 3 decades there has been an absolute explosion of technology that has not been linear. It's been absolutely exponential in all different directions at once, and it's like nothing else that happened previously. We went long decades before where basically there were not any significant developments in our business. As I mentioned before, powders have been around for a long time, and they improved you know, they tweaked the mixtures and they found that this worked a little better for contrast, and they put lycopodium powder in it to increase the adherence. They recognized that they wanted powders that weren't quite so sticky for certain kinds of surfaces. But these are kind of mundane, pedestrian little baby steps compared to the idea of exploiting a brand new physical or chemical property. So that's the kind of thing that's been happening with regularity in our business for the last 30 years. And we are almost in the position of someone trying to go up on the down escalator. We got to keep moving just to stay in the same spot, because so much development has happened so quickly and in so many different directions that if we want to stay current in our science, we have to keep our eyes on the publications and on the future. So everybody is familiar with ninhydrin. We found it working on quite a wide variety of surfaces. It has a familiar look to anybody who has been in this business for any length of time. Now I wanted to talk about the transition, because we're talking here today to a degree about transitions in technology. And I think that this is one of the first, if not the first, major, transition in the process of finding or detecting latent prints and being able to do something with them. In 1972, I was a new kid with the Ontario Provincial Police, and I had just had a fairly big case for the time. It seems a little laughable now that they went through this, but I was explaining to Alexandra last night about it, and he got a good laugh out of it. But the idea was that they had a promotional process then for, I don't even remember whether it was corporal to sergeant or sergeant to whatever the next step is. And there were 35 people in the group, and they had to write a very comprehensive written exam. And the exam was something in the order of 30 pages long. And the secrets or the questions on this were closely guarded. They were not allowed to remove anything from the room. And at the end of the exam, they found that one paper was missing. Well, nobody in that day and age had any sense of humor about these things at all, so they called in CIB. And CIB investigate homicides and other major cases. So you can tell that they took this rather seriously. And I was given these exams, and the stack of paper was something like this. And what they wanted was to find the fingerprints of the persons who had written the exam so that they would be able to do a subtraction and find out whose weren't there. And so I was using the only chemical that I knew for paper exhibits, and that was silver nitrate. And another part of the transition, maybe not everyone in this room is aware of, it was a pain to process paper exhibits in an aqueous solution because it took a lot longer to get them wetted. The surface tension, the resist of the paper to the water took a lot longer, so you had to really get it in there and douse it to make sure it was completely covered. It's not like sliding into an organic solvent where you just slide it in and you have a total immersion in half a second and total exposure to your chemistry. So I did something that speeded up the process. We had an old ectomatic processor, a paper processor. I'm probably talking Swahili here, I suppose. Sorry, I drift into the past every once in a while. It's a thing, it's an old people thing. But an ectomatic processor was a device about this wide, about this high, and it had a series of rollers and baths inside with developer and fixing agent, and when you were in the dark room, you would expose your, anybody know what I'm talking about? Did anybody do work in a silver dark room in their career? Oh. Oh, yeah. I need a drink. Kidding. Yeah, it is a hobby, but it's another thing that has just blown my mind how in 3 decades, which is a blink of an eye, large companies that had streets named after them are now just a kind of a fond memory in 3 decades. Manufacturers of paper and film and cameras and so on that were household words, and they've kind of faded into obscurity. It's quite surprising. But anyway, this paper processor had been replaced by something else, and it was sitting in the back room. So I put silver nitrate in the baths rather than developer, and I just fed the documents through so they went through like the wringer in a washer, and they were coming out the other side squeegeed and dried, semi-dried. And this was working very well. I was getting some wonderful fingerprints because, of course, we know that when people are brought to the fight-or-flight syndrome, and there's no better example of that than policemen writing an exam. They'd rather have both feet cut off than write an exam, in my experience. And then when their whole future is depending on it, they are sweating. So they were providing beautiful fingerprints on these documents. And the bad side to all of this was it happened in the summertime in Toronto, and we can actually rival Orlando or Miami or Largo for humidity at the wrong time of the year. And I noticed there was a radical fall off in the quality of the prints, and I was starting to lose the prints because of this migration of the salt. And it was very, very frustrating because the first group were coming along wonderfully, and I had to get something on everything. So I stopped to consider my options. I even thought about doing powder because I thought maybe there's a better thing, because this is obviously not, the prints are there and they're just blobs. So I was introduced to ninhydrin in a matter of days. We had heard about this newfangled thing called ninhydrin. So ninhydrin was brought in. I can't even remember now who it was who took through the mixing of it, but I started processing the exhibits in ninhydrin, and I was back to razor sharp, excellent quality fingerprints, just like that. And so for me, the transition was very, very quick. It's perhaps worth mentioning, too, the importance, and those of us who've been in this business for a while know about the importance of that sympathetic nervous system reaction, the fight or flight thing where we get a jolt of adrenaline and we leave far better prints. It's easier to get prints in a latent situation often than by saying, okay, well, we've got some good latents here, but now we need some prints surreptitiously. Here's a bunch of paper this person handled. If anybody's ever had that situation, you know that people just typically don't leave really good fingerprints unless they're motivated. And we had one, I had one very pleasant case experience a few years ago where there was a major bank in Canada, and transfer envelopes, money transfer envelopes, were being intercepted and torn open and the money taken out, and then these envelopes were thrown behind the copier machine. And these envelopes were plastic, kind of like a Purolator envelope. So I processed them in cyanoacrylate and wrote them in 6G, and I got just a ton of really good fingerprints. I mean, they were gorgeous, gorgeous fingerprints. So the bank was informed, and they had a group, a small contained group, probably about the same number of people as are in this class. They knew it had to be one of those people. They also know that they have to be very sensitive to issues like employee relations, the union, and, you know, bottom line. So I didn't want to upset their office chemistry, so we came up with a strategy where we created a questionnaire. And the questionnaire was, I believe, 10 or 11 pages long, and it basically had a little blurb that said, "You are no doubt aware of the recent series of thefts in our office. Do you have any suggestions for improving office security? Excuse me, do you know who was involved? It was just all nonsense and babble for 10 or 11 pages just to get them to touch the paper. And for all but one of the groups, there was the usual bits and pieces, you know, the little touches and fragments of ridge detail. But the last one was just covered in beautiful prints, and there were 23 identifications made to the prints on those bags. So it's a very sharp reminder about the importance of that kind of emotional intensity in terms of producing usable fingerprints. And I remember one of the cases I worked on in the very first part of my career where ninhydrin came through with flying colors. I got one forged check for a very large sum of money, and the investigator brought it to me and he said, I don't know what the point of this is, I'm just following orders, but he says, you're not going to get anything because everybody in the free world has handled this thing. Well, when it was processed in ninhydrin, there were bits and pieces as usual, but the only clear and usable print was the bad guy. So I found this time and again in my career. So now we come to a really interesting thing, because in the 1980s, ninhydrin was in huge use in North America. It was the reagent of choice, and we were doing great. Meanwhile, in other parts of the world, they wondered what we were smoking over here, because in Israel in particular, they were not getting these kinds of results. In fact, they thought that there was something fishy about the whole process. And in fact, they sent one of their lead people, their head researchers, to North America to look into this ninhydrin business and see actually what was going on. And this is where we come into the story of the flea, because we found that there were a lot of factors that nobody had really looked at. We figured if we're sitting in our lab in Toronto and getting wonderful results with this, the same situation is going to be duplicated in every other lab in the world. Doesn't happen that way. You have different ambient climate. You have, of course, temperature and humidity considerations. You have local diet. You have pollution concerns. You have different manufacturers of substrates, different types of paper. And I'm sure some of you, or if not all of you, know that pH is a huge factor in our solutions. We've had chemistry that has either not worked or sort of worked a little bit, and then you alter the pH slightly and whoa, all of a sudden the results have just jumped through the roof. So all of these things, either singly or in concert, can have a huge effect on how good your results are. So they found out that the results were really not that great with ninhydrin, the formula that we were using, just straight ninhydrin. So this actually was a good thing because it generated formal and constructive research on a large scale around the world. Up to this time, research was largely ad hoc, and it was done by folks with all due respect and great affection, because I'm one of them, who really didn't have any background in research, just had an insatiable curiosity and didn't like mysteries, so that when something happened, you wanted to figure out why, and in our own fumbling way, we would come up with something and think, whoa, this is great, let's do it. But this is the point in my personal experience, and I'd be delighted if anyone has examples of it happening earlier. But in our business, the fingerprint identification and detection business, this, to my knowledge, was the first time that formal research, proactive formal research, actually entered the picture, rather than just taking advantage of happy accidents, as had been the case before. So the Israelis mounted comprehensive research into the ninhydrin reaction. And of course, they got into the structure of the molecule, and as my old friend Roland Menzel used to call it, methyl ethyl chicken wire. They would go to the very structure and alter. So if there was an OH on this end of the molecule, they would put an N or a C or something, and they would create all of these different spin-off analogs or extensions of the ninhydrin molecule. And some of them were 5-methoxy-ninhydrin, benzo-F-ninhydrin, 5-methylthione-ninhydrin, and naphtho-F-ninhydrin, names that just roll off the tongue. Most of these did not produce anything. They produced, in some cases, a blue color mode or a green color mode, but for the most part, many of them just didn't improve anything at all. 5-methoxy and 5-methylthione-ninhydrin both were promising. Some were difficult to synthesize. Some were expensive to synthesize. And if you have ever tried to find something that is not mass-produced, that is only a research chemical, you are going to pay through the nose. I did some early experimentation with cyanoacrylate. I had ethyl cyanoacrylate, methyl cyanoacrylate, propyl, and butyl cyanoacrylate. And actually, by far the best results I got was with butyl cyanoacrylate. The polymer that formed on the ridge sites is very, very white as compared to with either ethyl or methyl. And the results were just really terrific before the introduction of dye. But for a tiny little container, less than the little one-shot usage you get in the dollar shop of crazy glue, I think it was 80 bucks in 1980. So if you translate that into today's dollars, that's an awful lot of money, so I didn't pursue it. And in any case, it didn't make any difference when you go to the next step, which of course is the dye step, and then the visibility of the polymer becomes academic. So all of this led to something that was good and was very, very strong, and that was diazofluorine 9,1, or as we call it, DFO. And it was introduced in 1990 by Tony Pounds and his group from the UK, but not without a lot of work by other people. And that's the thing that it's important to remember. You usually attribute one big breakthrough to one name or perhaps two names. But it's important to remember, I think, that they have stood on the shoulders of others who have taken it to the point where they could do what they did. So people like Joseph Almog in Israel, and people like Tony Cantu at the Secret Service, and others were all part of this international community, and they shared information, and they ultimately all contributed to the Pounds success in around 1990. So we have DFO, and we've had reports that it is 2.5 times more sensitive than ninhydrin. That's awe-inspiring when you think of it, 2.5 times. How many of us have been in a case, perhaps, of a serial killer with a note or a piece of evidence where we have a fragment and it's close but no cigar? And if we had had a reagent that had a longer reach, would it be possible that in that particular case it would go from an uncomparable fragment to a usable latent? I mean, the possible implications of 2.5 times as sensitive are earth-shaking, really. And of course, in our business, we know as well that we don't have to make a huge difference to make all the difference in the world. The average Joe, the layperson, could look at 2 prints, one before and one after, and see absolutely no difference in the two. But if we can see just one characteristic or two characteristics extra or more clearly than we saw on the other side, we can often go from, it could be him on a downgrade into the following wind, to it's him. And the average person can't even see the difference in the two. So if you take 2.5 times as sensitive, that's earth-shattering. It had a strong color mode, like ninhydrin, and a strong luminescence mode. It was excited by green light, and you had lots of choices here. And of course, by 1990, we've had 10 years of light sources. So the first light source came out in around 1980. That was, depending on who you talk to, it was either the Polylight from Australia or the Lumilight from Canada. Personally, I think they got a tie. I think it was research that had to happen, and it happened concurrently and independently in different parts of the world. Much like the development of cyanoacrylate, which I'm convinced in my own mind happened pretty much concurrently in the UK and Japan, just about the same time. So you could use a YAG laser, you could use an argon laser, you could use a semiconductor laser, you could use a forensic light source. This stuff is very forgiving. It just likes green light, and it doesn't really matter so much the actual wavelength. The absorption band is quite broad, and that means you hit it anywhere in the green, and it's going to fluoresce. And then it's just a case of having the right filters, and Bob's your uncle. But there has been a slow and uneven acceptance, at best, for DFO in the identification community. More expensive than ninhydrin, and the researchers tried to point out that, yeah, the initial purchase is expensive, but you're using such a tiny amount to make a solution that the actual expense drops considerably. But anyway, you know, as I said before, we were never meant to be revenue generation or revenue savings. We are not in charge of cost dropping for our respective agencies. So it's always been my position we have to sell the improved results to senior management in order to implement new technologies. Anyway, that's another story. So it requires an expensive light source. Now that has dropped. Of course, the term expensive is a relative term. Expensive depends on how much money you have in your jeans. If you've got a couple of $1 million, then $10,000 is not that big a deal. But if you don't have a huge budget, then it becomes a big deal. So for a variety of reasons, some of which are quite legitimate, many police forces went through that decade from 1980 to 1990 without any sort of light source at all. And there was a kind of a creeping, grudging almost, acceptance of luminescence as a detection strategy. And so finally we get to 1990, where it is, I would say, not uncommon for police departments to have some sort of light source. Here's another thing. It requires more time. And time is something that is in many cases harder to find than money. We are in a growth industry. GM should be so lucky. We never have to worry about more crime happening requiring our attention. That's never been our problem. Our problem is getting the resources to deal with it. And so you get more fingerprints with DFO. There is an extra step involved. The photography, at least initially, requires more time and a little more thought than does copy stand photography, which is what you would do with ninhydrin. I mean, we had it set up, I'm sure you folks had the same, where you would have a copy stand, you would have a set exposure, the lights would be there, you just put something down, click, boom, done. So in 10 seconds, you've taken one photograph, and that's a conservative estimate. It's not quite that easy when you've got a fluorescing fingerprint. You got to set things up, and you don't normally have the resources to leave everything all set up and know the exact exposure. Because, of course, when you're dealing with ninhydrin, you're dealing with an absorption reflection situation where you have a fixed dynamic range, and you know that except in very, very unusual circumstances, one exposure is going to do it for everything. But when you've got a variable dynamic range, as is the case with luminescence as your target, then your exposures can be all over the map. They can be very, very much in the normal range, or you could have something F8 at 30 seconds or a minute to get one that's really out there. So for all these reasons, you need more time. So the transition is such that in 1990, both reagents were in use, and it continues to the present. DFO often used as a niche technique. So when it's time to bring out the big guns for the big case, this is the DFO situation. And by the way, before I continue, you'll notice there was a questionnaire for each of you that I would ask you to fill out if you haven't already. And it talks about your specific experience with the reagents we're talking about here. And it will not leave this building. In fact, it won't be in existence at the end of the day. It's just to prove a point. And I'm not presupposing, and I'm not expecting a particular outcome. I'm very interested to see what the results will be, because we have a very eclectic group here. We've got some people who've been, you should excuse the expression, around for a few years, and we've got some young folks who are probably right in the height of their careers. So it's going to be interesting to get a broad range, and we've got people from all over the country. So it's going to be interesting to see what the response is going to be on those questions. And here's something else. There's an old joke that I won't repeat, but one bad thing can really do a lot of damage. It takes a long time for somebody to build a bridge and someone with 2 seconds and a match to burn it down. And DFO was already having struggles getting adopted, and then about 10 or 12 years ago, there was a bad batch of DNA produced, and the results were terrible. And then there were a lot of people who probably, I don't think I'm presuming too much, but were happy about saying, you see, this expensive stuff doesn't work. It's garbage. It doesn't work. Because I took that same stuff, processed it in good old anhydrine, and boy, you wouldn't believe what I got. And I think part of the thing, too, another factor in our business is we don't like change. Change makes us cranky. People don't want to be told, just when they get used to one thing where they got a lot to do in a short period of time, there's something new to do. We don't like the word new as a discipline. And so this makes it difficult, because new usually means more money, more aggravation, and less time to do other things. So these bad batches set DFO back even further. And few comprehensive studies were done by police agencies. So they didn't compare at the time. They didn't sit down and do a comparison and say, look, this is the quantified result. You do it with anhydrine, you get X number of prints. You do it with DFO, you get 2X or 3X or whatever. Nobody did that, really, to my knowledge. I apologize if anybody's aware of a comprehensive study that was done, but I certainly didn't see it. And when they did have an occasional report on the sensitivity of DFO, the reports are largely ignored. And the results of this is that the routine and preferred use of DFO is pretty rare. And when you think of that, DFO has been around since 1989 or 90. That is 2 decades. And for something that was 2.5 times as sensitive as its precursor, I find that extraordinary. Like, would we not be in the business of looking for something that would give us 2.5 times the number of prints? Because again, remembering that we are event-driven, not dollar-driven. So as a result, that has been a problem. The sequential use of DFO and anhydrine, which is what everybody is accepting now pretty much, is even less frequent. Again, it's a time issue. It's a money issue to a degree. So we know that the use of DFO and ninhydrin together produces more than either on its own. Now, why would that be? You have a couple of things going for DFO over ninhydrin. First of all, DFO, as a subject of peer-reviewed articles repeatedly, is 2.5 times as sensitive as ninhydrin. Secondly, it relies on luminescence as the detection strategy, which we all know is exponentially more sensitive, orders of magnitude more sensitive than simply staining something a different color. So why on earth would it be possible for ninhydrin to come and then be able to add to what DFO got? Well, there are at least 20 different amino acids which are possibly present in our residue at any time. And that can change from day to day, emotional state to emotional state, diet to diet. We are what we eat. So the possibilities, the permutations of that are probably more than the state lottery. So that means that it's not dealing with a common all the time. The second part of this is that ninhydrin and DFO react at different speeds and to different degrees with different amino acids. So even though DFO goes like a house on fire on A and B, it may not like C and D all that much. Whereas ninhydrin can come along and say, well, I like C and D, bingo. So you actually have the ability to fill in the blanks or to complement, even though the DFO is a better reagent overall. So this is something that we know to be true, but even though it has been done, it's not being done. So what are our current lab realities? And I expect I'm going to see some head nodding on this one. Operational budgets have been slashed. We are in a nasty recession. Training budgets always get cut. So anytime they're looking to pluck the maximum number of feathers out of the goose with the minimum of hissing, they always go for training budgets because that's the one with the least amount of reaction. Because there isn't an immediate negative reaction to that. There is in the long term, of course, because we know what happens when training budgets, when people don't get trained to do their job. It's just it takes a long time for the bad things to kind of manifest. But it's a familiar and repeated target when times get tough. And any existing research budgets are cut or eliminated because, of course, that is another feather that doesn't draw a lot of hissing. And if you have, I'd be interested just by a show of hands, who actually has a formal research budget or a component to their budget, a research budget? Anyone? Case in point. Because as a police agency or a series of police agencies, we are, to that degree, reactive as opposed to proactive. We depend on research for new techniques and so on for outside agencies, and then we avail ourselves of the results of that research when it comes out. But we don't, as such, have a research component. But if there is one, and I have seen some police forces that actually do have a research budget, then they get quickly cut and eliminated too. And at the same time, the number of exhibits that are submitted to us for examination are either holding or rising in number. So crime is not going away, and typically crime rises in times of recession. It doesn't fall off. So these new techniques mean more man-hours involved, and that can either mean a lot of overtime or more staff. And I think everybody would agree that it's a lot easier to get equipment than it is to get another person, because that's always a lot more expensive for the department in the long run. They would rather pay for an expensive piece of equipment than to add an additional staff member. Of course, they'd really rather not do either. But if they're going to do one or the other, it would be the equipment that would be chosen, because it would be a one-time upfront expense with no commitment down the road, like pension and benefits and all the other stuff. We have had increases required for not only equipment but lab space, because you need a place to do this in, and you can't be doing the same thing in the same spot all the time. So that means expanding your lab area, and we all know how difficult that is. It means more photography, because if you're finding more things, you got to photograph them all. And maybe you have to photograph them at both stages if you're doing a multi-stage process. It means more fingerprint comparisons, because anything ultimately that you find after it's been photographed has to be evaluated and then compared. And finally, it's going to mean potentially more time in court. So those are the realities. And lastly, about court, we know that in the current age we are more subject to adversarial review than at ever in the past. I started my career in 1971, and from then until the time I retired in 1999, I had given evidence on fingerprints about 65 times. And in that time, I had been on the stand for considerable periods of time, a couple of days in one case, and I had the usual stuff. There were directional questions on continuity. They tried to play the point game. You know, if you saw one fewer points here, would you still be prepared to make this call? They would say they didn't see this point or whatever, these kinds of just sort of nibbling around the edges. And then, of course, the, you know, officer, can you tell how long that fingerprint has been there? No, sir, I cannot. I see. So that print could have been on that plastic bag at any time from its manufacturer until it came to you as evidence. Yes, sir, that's correct. In that case, my client's fingerprint could have been on there when it had a ham sandwich in it rather than 5 grams of cocaine. I can't exclude that possibility, sir. That kind of questioning. But never did anyone in my career suggest that it was junk science. Never did anyone bring up to me where someone had made a bad ident. And never did anyone suggest to me that it was confirmation bias, that I found this because I wanted to find this. So this was a whole new experience for me after I retired, to see what was going on, and then thinking, you know, I'm kind of glad that I've moved on to a new phase in my career, because who needs this? And then, has anybody here been involved in a Daubert? It's probably coming, because I've talked to people fairly recently who have been. But as luck would have it, 2 years ago, actually 4 years ago in our province, there was a homicide. And it happened in a small community that we're not used to looking at a lot of exhibits anyway, but homicides in particular. So we had a homicide in a small community, and the ident officer examined these items by cyanoacrylate and rhodamin 6G. He photographed some things, and then he judged them not suitable for comparison, and he stored everything away for the ultimate court case. 2 years down the road, he attends a class at our Ontario Police College, and he kind of gets rejuvenated or pumped, and he pulls out his stuff because court's coming up, and he figures maybe he's going to get a second opinion. So he sends his DVD bearing his images and the other court stuff onto my old department, the department I used to manage, and asks for a second opinion. So one of the people in there, who is a certified latent print examiner under IAI, got the case and made 3 criminal idents. And it was confirmed by his colleague, who was another CLPE. And when the Crown Attorney, the prosecuting attorney, got this information, he went a little bit ballistic. He's saying, what's going on here? One guy says there's nothing, another guy says there's 3 criminal idents. What is this, psychiatry? And so he said, I want an outside opinion here. He said, I want somebody to review what these people are saying. So they gave him my name because at the time, I don't know about now, but I was the third CLPE in Canada. So I was asked to review this. And right away, I knew I was in a different reality from 10 years previously when I had been working actively in my career. So in my previous career, the process would be, if Tracy and I were in the same audience, she would come and say, I've got something on the comparator I want you to look at. So I would go in and I would go, yep, that's him. She'd give me her notes and I would write in where she had put down 1R1 identified left ring Joe Blow. I would put confirmed January 25th and then sign my name. And that was our confirmation process in-house for the bulk of my career, my whole career. And we had the written policy that nothing was reported outside our lab until it had been confirmed in writing by a peer. So I knew I was in a different reality here. So I took the prints one by one, and I made a little PowerPoint of them, and I examined them without ever looking at the known impressions. And I made 11 pages of notes, and I put in markings, what I found, because of course this is ACE V. You got to analyze something before you get into comparison. And I'll tell you, it doesn't work just in theory, it works in practice, because I had a huge comfort level when I finally looked at the knowns. So when I went into court, he didn't want to know about how I felt if I had one less point. He didn't care about the continuity of the exhibits. He didn't care about how long fingerprints last. He wanted to talk about Mayfield. He wanted to talk about Shirley McKee. He wanted to talk about confirmation bias. And I felt so good that I had followed this procedure, which was totally different from my career. And as a result, the whole court experience was a pleasure. And I say that quite honestly. I was having fun on the stand. And I always did sort of enjoy court. It's only the days and hours before it that I always got the butterflies in the stomach, so never went away. But anyway, so because of Daubert and McKee and Mayfield, we have much more adversarial review, and that means a lot more times when we're going to end up in court, whereas in my career, a bulk of the time, as soon as they found out there was fingerprint evidence involved, they couldn't wait to deal. That doesn't happen so often anymore. So these are our current lab realities. As I say, our function is event-driven, and we usually understand that, but it's important for us to make sure that our management understands that, because they don't always. They are one step removed from it, and quite rightly, they have the administration of the budget, they have the reins of control on allocation of manpower and money, and they have difficult decisions to make. So we have to make sure that our name always gets in the hat. But we are gradually, in my opinion, being converted to dollar-driven. And there's a difference, as I say, between dollar-driven and dollar-dependent. So we have to make choices between what we see that needs to be done and what we can afford to do. Now, I come back to Indanedione, which is a ninhydrin analog, developed in around 1997. The U.S. Secret Service, Robert Ramatowski and his group, the University of Pennsylvania, Madeleine Julier and her group, and the Israeli police force with Joseph Almog and his group. These were the movers and shakers, basically, who are responsible for the introduction of this. And last I've listed, certainly not least, but because they've made a huge contribution, but the Australian Federal Police, Chris Leonard and his group have also contributed to this. So this came in, as I say, around 1997, and these are my comments or opinions. The color mode intensity is less than ninhydrin or DFO, but who cares? Because if you're going to get the most out of DFO, you got to use a light source anyway. You can't depend on the color mode. Anybody who's ever used DFO knows you record what you get in the color mode, and then you turn the light source on it, and you probably got 15% or 20% more, because the longer reach of the luminescence over just simply staining it. It can be stained. The chemical can be there on the ridge site, but we just can't see it. So we need the light source to be sure we're getting all that's there. But it is an intense yellow fluorescence. And when I say intense, I mean intense. The Australians have rated it as 10 times as sensitive as DFO. And the initial recommendations for this were for moist heat, same conditions as ninhydrin. And excited by green light, and again, it's just as forgiving, just as open to excitement with any kind of green light as is DFO. It likes the laser at 532. It likes forensic light sources 505, 530, even 555. Just have to change the viewing filter. So the orange or red barrier filter for viewing and photography. And on occasion, the red filter may reduce unwanted background fluorescence. So the fluorescence is more of a lemon yellow than a yellow-orange like you typically get with DFO. So here we have Indanedione, and perhaps here we have DFO. Perhaps we could just turn the lights off just for a moment so you can actually have a little better look at the can you see the color difference? How there's the Indanedione is like a lemon yellow, and the DFO is more of a yellow-orange. This can have certain implications down the road in advanced photography, in isolating that fluorescence over the background. Okay, thank you. So the color mode is weak. In some cases, it's non-existent. But it has this intense fluorescent mode. And just a little bit of personal history on this. I was lucky that one of my best friends was one of the top researchers, Joseph Almog from Israel, and I got in on the bottom floor, as it were. And he was very excited about this new stuff, and he sent me some, and I was experimenting with it, not in an organized way, but just kind of an ad hoc, let's mix some up and try it out kind of way. And I was really impressed in that perspective of the results I was getting. And I am a contract teacher at the Ontario Police College. I teach 3 courses a year down there. So I introduced it into the course we were teaching there. And those of you who have taken the Ron Smith course from me, the Finding Latent Evidence with Chemistry and Light, this is, to all intents and purposes, the same course we teach at the police college there, and I started teaching it in 1996 when I was still with the OPP. But one of the things that has come and be different is that in about about 2003 or 4, when I found out about Indanedione, I introduced it into the chain of amino acid reagents that we were using on the college course. And saying to people, you know, this is not a basis for comparison. This is not enough of a study. You know, it's like if I ask 2 people in the room, how do you like your president's track record so far? And one person says, oh, I think he's great, and the other one says, oh, I think he's a disaster. It would be wrong for me to say 50% of Americans think he's doing a great job and 50% don't. You don't have enough of a database. And it's the same thing with this. I can't make those kinds, I shouldn't, and I've been burned enough to know I can't make those kinds of judgments on such a small sample. But what it did do was prove this stuff does work. How much and when remains to be seen, but it does work. And what I could see in the limited comparisons I was doing was that it seemed to be much more sensitive, much more intense than the DFO. And I occasionally would cut a piece of paper in half that I had put prints on, and then I could actually see where on one side with the DFO, the other side was heightened and much more there with the Indanedione. So a lot of the people attending the classes were seeing this kind of thing as well. And I also have my own consulting business. I have a full-service fingerprint laboratory, the only one in Canada, and I have everything that any major police force has. And I was blowing the horn of this Indanedione to some of my corporate clients, and one of them said, well, I've got a case I'm going to give you the exhibits on. It's company checks that were stolen, obviously an inside job. There's a big box of checks that came to the financial officer, and there's 4 checks missing. And they were later cashed for a total of $1.4 million in somewhere in the Caribbean at a casino. I didn't know the whole story there, but I didn't need to. It was just they wanted to get fingerprints done on it. And he said, the local regional police force here has a file open through their racket section, but I want to give you the exhibits because they don't have this ding-dong stuff you're talking about. That's a quote. So I said, okay, because now I got to put my money where my mouth is. And as much as I am enthusiastic about this, when push comes to shove, it's very hard to take your foot off the rock that has held your weight for 28 years and put it onto a new rock. So I thought, well, I got to. So I processed the checks in Indanedione. And as I say, at that time it called for heat and humidity. Well, after the heat and humidity, those checks looked exactly like any piece of paper on your desk. And I went, oh boy, have I made a fearful error here. And then I put the light source on them, and there were 17 identifiable prints. There wasn't a trace of color mode, but there were 17 identifiable prints by light source, and 7 of them were suitable for APHIS. And it ended up they made a cold hit on an organized crime figure, and that led to 5 more arrests. So you can imagine how happy everybody was. So I should have quit then because I'm batting 1,000 at that point. Well, I'm not batting 1,000 anymore, but I can tell you my batting average is still pretty darn high because I really endorse and like Indanedione as my first line reagent. So you get this intense color mode. This is another case I worked on just as an example, and this is an example of a relatively strong Indanedione color mode, and it is a criminal ident. So this is just the color mode, but then that is the fluorescent mode. So there's a ton of stuff that you miss if you're not using both. Now this is true even with DFO. You could have much, it won't be that dramatic I don't think, but you could have pretty much that same situation with DFO. Because, you know, I keep repeating it, it's kind of a mantra, but luminescence is just orders of magnitude more sensitive than staining something. So what issues do we have? We've had source issues. In fact, we had one today, which I'm going to show you because seeing is believing. You have issues with the quality and the purity, and I'm a real stickler for this because I saw what happened to DFO. You know, one bad rumor, and it just knocks the props out from under what in other areas is a really fine reagent. DFO is a wonderful reagent. It's just one bad batch really hurt its reputation. So I'm very sensitive about issues of quality and purity, and particularly when you've got the early stages of something new where some people are making the equivalent of bathtub gin. I mean, labs are making it in their own places. They're starting to synthesize something they don't have 10 years experience at, and they come up with, in some cases, garbage. And the formula has changed. It has evolved or mutated from the early days at least 4 times, if not more. There is the Israeli formula, the British formula, the Australian formula. Oh, and I could add the Canadian formula too, because we had a hand in it in Canada as well. You have shelf life issues. How long does it last on the shelf? And you also have the idea of what do you do after it's processed? Do you use heat? And if so, what temperature? How long? And do you use humidity or do you use dry heat? And again, what percent relative humidity and for how long? So you have all these issues. Then you have the addition of zinc chloride, which is, I credit the Australian research group for this, and it's huge. And it's really interesting because if we go back to one of the developments of ninhydrin that Roland Menzel introduced in the 80s, was the introduction of zinc chloride as a supplemental step to ninhydrin processing. Has anybody done zinc chloride treatment? Yeah? Any luck? All the time or sporadic? Oh, you mean it's part of the, it's a one-step thing then? Well, that's interesting. I'd like to talk to you about that. At any rate, my experience with zinc chloride is that it was sporadic at best, but it did make a difference. And once again, it exploits luminescence rather than simply staining. So just as in that previous example of the palm print with the Indanedione, you can have something there where the chemistry is there, but it's not manifested in the visible mode. You switch on the lights and wow, there it is. So I have had occasional success, and here we find that it's incorporated into the Indanedione formula, and it just works like nobody's business. Just wonderful stuff. And we had the issue of pretreatment and the exhibit humidity. So this is another complication, and I don't want it to sound like I'm blaming him. It's not that at all. I guess I'm inescapably grumpy about change to some extent, because when you get used to something and it works, nobody likes to change. You're liberal till you get what you want, and then you become a conservative. Anyway, Robert Ramatowski is the one who explored and identified this as a factor, that it makes a difference what kind of exposure to humidity your exhibits had before they're processed. So he even suggested different treatments depending on that. Okay, now we come to the issue of quality and consistency of the product. And this is an example of some Indanedione, the scientific word for which is crappy. And this is the difference in the precipitate between 2 batches. Now, you don't have to be a scientist to see that those 2 things are not the same. And if they don't even look the same, how on earth could they possibly be doing the same job? So this is where I come back to the idea of knowing your source for Indanedione. It should look like a pure, uniform, refined yellow powder. If it looks like something you swept off the floor of a barn, throw it out. And I can show you some stuff that actually falls into that category. Now we come to something else that's very interesting. Ninhydrin has, now I expect, and please feel free to nod freely if you're in agreement with this or if you had this experience. 25 years ago or so, I had several hundred paper exhibits on an organized crime case. And I treated them with ninhydrin, and I got a ton of fingerprints. And I marked them all and photographed them. I made multiple identifications on multiple subjects, and then I put everything into storage while I waited for court. And when court came, I pulled all my stuff out to review it, and to my horror, I found a whole bunch of new prints. And I thought, how could I have missed those? Anybody had that happen? Yeah, I see some heads nodding. How could I possibly have missed these prints? I talked to my boss because I was worried about getting roasted in court. And he said, no, that's an anhydrine. He says, you just can't control the stuff. It's going to come when it comes. So I photographed those, and would you believe it? 2 more people were identified. So that was a huge lesson, and I've never forgotten that. And then I had another case, multiple paper exhibits processed in anhydrine, multiple identifications made on it. I placed them in storage. I had a court a year later, and they disappeared. So they weren't there anymore. The things that were there had gone. So we've got the 2 things happening here. You know, what's going on? What is this stuff? Is it, you know, it's very unpredictable. So this brings us to a comparison between ninhydrin and DFO. I seem to be jumping, folks, but there's a point to this. The ninhydrin is exclusively a stain reagent. That is, it colors the prints. DFO is dual mode. You get color and fluorescence. DFO fluorescence mode is 2.5 times more sensitive than ninhydrin, but ninhydrin can develop added ridge detail after DFO. What's going on? What's the deal here? And how is it that with DFO being arguably 2.5 times as sensitive as ninhydrin, we can actually still fill in the blanks with ninhydrin after DFO processing? Well, we know that the ninhydrin product, the Rumen's purple, is unstable. And we also know that it can be incomplete and it can take a long time to complete. And the DFO reaction is also incomplete. So we have the conclusion, the inescapable conclusion, is that the DFO and ninhydrin react at different speeds and or to different degrees with different amino acids. So we have, depending on the literature you read, 19 to in the mid-20s possible amino acids as potential components of this finger residue. And the indanedione and the, or not the indanedione, pardon me, ninhydrin and DFO react differently with them. So this means even though DFO is a more sensitive reagent overall, it still means that the ninhydrin can come in and complement or add to the total reaction by subsequent processing. So let's take a look at indanedione versus DFO now. Numerous comparative studies have been done. Probably there has never been something more tested and tried than these 2 reagents in at least 5 countries with different formulae, different samples, and different donors, different climates, with very different results. And until fairly recently, there were the adherents to DFO as a fairly committed group, and then the adherents to indanedione as an equally committed group. But what's been interesting is something that I've watched with great satisfaction. The groups from the different parts of the world have been exchanging exhibits, working together, so you've got JFO research groups from around the world to try and give meaning to the differences in these results over the years. And surprisingly, the picture is becoming clearer, and just about everybody now is of the opinion that the indanedione is the better reagent. So Robert Ramatowski did a comparison and a paper in 2008, and this was quite telling for me, because you have, instead of preparing samples, what he did was to, oh, before I get to that, and one last thing I will say, I apologize for jumping around, but I asked one of the main researchers, Joseph Almog, early in the game, if there was any protocol or rationale for processing sequentially with indanedione and ninhydrin. And he said no, because the indanedione is a very efficient reagent for amino acid. It reacts efficiently and quickly with all or most of the available amino acids, so there's really no point. It doesn't leave anything behind for subsequent processing. But this was a rather dramatic example here of how indanedione can be used after DFO. It's not recommended because I would always save the exhibits for my first line reagent, not degrade their condition in any way. So I always go with my best first, but this was an experiment to show a certain thing. So what Robert Ramatowski did was take just ordinary envelopes he received in the mail, a large number of them, and process them in DFO and then record the results. And then he would subsequently process them in indanedione and record the results. And it's a subtle difference, but on this side there is more ridge detail than there is on this side, and this is a cut piece of paper. And another example, so again, this is the same piece of paper processed first in DFO and then in indanedione. We have the DFO version and then the indanedione version. I think you'll agree these are pretty substantial differences. And again, the DFO and the indanedione. Now, not everything that you see in the indanedione thing here is a useful print, but it shows you the extension of the reach. And many of those are, in fact, identifiable impressions. So you have a suggestion of something going on in the DFO version, but you've got the real deal, or at least more, with indanedione. And this is what caught my eye. This is what had real meaning for me, to show how the reach is so much greater with indanedione. So, quick note on technology transitions. So when we went from silver nitrate as a discipline, silver nitrate to ninhydrin back in the 70s, or in some cases I suppose even the 60s, it was a very quick transition because there were no increased chemistry costs. Silver nitrate's expensive stuff, and it certainly wasn't any cheaper than, or more expensive, was about the same, I would think. If anything, probably ninhydrin was cheaper. No increased time costs because you just substitute one for the other. The only difference in time would be because of the extra stuff you would find with ninhydrin over silver nitrate. Minimal equipment required. Of course, we got into humidity chambers or incubators, but we also know about a lot of very creative alternatives involving irons and kettles and so on. No increased training costs because you didn't require anything too esoteric. It was simply dipping a piece of paper in a solution and letting it dry. And it's a stain method to stain method transition. So instead of staining something brown, you're staining it purple. And no change in photography to speak of either, except the addition perhaps of a green filter for added contrast. The only change is more fingerprints, essentially. So very rapid transition, and ninhydrin became the reagent of choice, the go-to technique for paper very quickly, and it stayed that way for a long time. Now let's look at the transition from ninhydrin to DFO. Increased chemistry costs, both real and imagined. Increased time costs, forensic light source required. Significant training issues, because it's a little more to it, mixing up and using DFO and the light source as well. Stain method to fluorescent method, so this is a huge transition. Significant difference in photography. Many changes, including choice of sequential processing, which we had never had to think about before I should say before the introduction of physical developer, but Alexandra's going to get to that. So the transition from 1990 to now, 20 years, has been slow to non-existent in many places. There are many labs where their first line of processing is still ninhydrin and no use of DFO at all. So that has been the result, a very, very different transition. Now the DFO to Indanedione transition, we're in it. No increased chemistry costs. If anything, Indanedione is a little cheaper. No increased time costs, because if you do them both right, it's quicker actually to process Indanedione. The same equipment requirements as DFO basically. The same training requirements, same photography. So it's a fluorescence to fluorescence method, and that transition is not as onerous or as radical as the one from ninhydrin to DFO. The only change again here, or the biggest change, is more fingerprints. So it's been a cautious but steady transition, and I've found that there's been a greater transition so far from DFO to Indanedione, or in some cases from ninhydrin to Indanedione, than there was the previous transition for all these reasons. So the 1990, the forensic light sources were restricted to medium and larger agencies. And after 2000, I think it's safe to say that forensic lights are in virtually every agency now. And if they don't have them, they should have them. And I think the pressure is on now that you really can't be a functioning lab without a forensic light source, functioning to the full extent of your abilities. So the forensic community is much more adapted to fluorescent techniques than it was even 10 years ago. And labs are under greater adversarial scrutiny, and as we know, the thrust of any defense argument is very frequently based on what was not done as opposed to what was done. That's what they want to hear about. So the recommendations we're making as a result of this is for sequential processing for porous exhibits, because we have different targets. We have amino acids, the DFO plus the ninhydrin or Indanedione. Indanedione would be my first and strongest recommendation, but if not, at least the secondary position should be DFO plus ninhydrin. And then to take advantage of the lipids, which are such a common ingredient, the oil red O and the physical developer. So that's it for this session. Anybody have any questions or comments? Okay.